This is Physics 2212 Lab 2, Magnetic Field of a Bar Magnet. This experiment is going to measure the distance dependence of the magnetic field due to a small bar magnet, and compare your measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields derived from the Biot-Savart law. The results I obtained from this experiment is that the magnetic dipole moment is approximately equal to 1.673 joules per Tesla. The magnetic field is proportional to distance to the power of negative 3.28. The procedure of this experiment is first to find the direction of the magnetic north by aligning your phone with the Earth's magnetic north-south axis, and then put the bar magnet at one end of the east-west oriented meter stick and place the phone perpendicular to it. Then slide the phone slowly along a line perpendicular to the meter stick. Lastly, move the phone along the meter stick on axis and at 45-degree angle. Then record the magnetic field component on the spreadsheet. The physical model we use in this experiment is Biot-Savart law. The magnitude of the magnetic field can be expressed as the magnitude of the bar magnetic field equal to K times R to the power of n. Since we are exploring the correlation between the magnetic field and the distance, we can assume all the other constants are the same except for R. So we express them in capital letter K, and n is expected to be -3. So this slide shows the data measurement for the magnetic field on the axis. By transforming the exponential equation from the previous slide to the log function in this slide, we can plot on the graph using this linear equation. So we can find n is approximately to -3.28. And since n is expected to be -3, the percentage error is about 8.5%. And since the y-intercept on this graph is approximately to -14.91, so k is about 3.38 times 10 to the power of -7. And by implementing the Biot-Savart law, we can calculate the absolute value of the magnetic dipole moment. This slide shows the magnetic field measurement off-axis. We need to place the phone at distance d perp on the x and y axis from the magnet, and we need to correct the magnetic field in the y direction by subtracting the measured data by the Earth's magnetic field. For the coding part, the first step is to update the magnitude of the magnetic dipole moment to 1.674, and then we need to implement the Biot-Savart law to create a function for the magnetic field. The next step is to create 6 arrows representing the magnetic field at 6 different observation locations, 2 on the axis, 4 perpendicular to the axis. And lastly, we need to create another arrow to represent the magnetic field 45 degrees from the axis. The results are shown in the graph. So the 2 orange ones are representing the magnetic field on the axis, and the blue ones are representing the magnetic field off the axis, which are pointing to the opposite direction. The purple one is representing the magnetic field 45 degrees from the axis. Lastly, we come to the reflective questions. So what if you laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? The result would have significant error as Earth's magnetic field would impact the measurements of the magnetic field created by the magnet. The second question is that what if you redo the experiment instead of using a single magnet, you use the 2 identical magnets stuck together end to end? So the answer is that the direction of the magnetic field would be the same as before, but the magnitude of the magnetic field would be twice as much.